I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, the CSIAC. Today's presentation will examine the topic of cyber monitoring. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. The briefing slides and webinar will be posted on our website within a couple of days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My great pleasure to introduce our presenter for today's webinar, Dr. Kamal Jabbour. He is a senior scientist for information assurance with the Air Force Research Laboratory's Information Directorate in Rome, New York. Dr. Jabbour serves as the principal scientific authority and independent researcher in the field of information assurance, including defensive and offensive information warfare technology. He conceives, plans, and advocates major R&D activities, monitors and guides the quality of scientific and technical resources, and provides expert technical consultation to other Air Force organizations, DoD and government agencies, as well as universities and industry. Dr. Jabbour is also the creator of the Advanced Course in Engineering, which develops the best ROTC cadets into future cybersecurity leaders. I will now turn the presentation over to Dr. Jabbour. Good afternoon, Kamal. The floor is now yours.
Good afternoon, Steve. Thank you for this introduction. For those who do not know that, Steve and I go way back when we both worked in the College of Engineering at Syracuse University around the turn of the century, the 21st century, that is. This afternoon, I'll be talking about cyber monitoring, a topic in an area that I've been working on for literally 45 years now. And the one thing that is important and fundamental to monitoring is that you cannot monitor what you cannot measure. If you say that you're monitoring a quantity, my question to you is, how do you measure it? What are the metrics? What are the quantities that you are measuring so you can monitor it? In a nutshell, we know how to measure and monitor physical parameters. That we have been doing for ages. We can weigh matter, we can measure speed, we can measure time, so we can monitor these parameters. Yet, in the cyber world, many have developed an obsession with watching. We like to watch has become a profession. It is essentially voyeurism for all intents and purposes, deriving satisfaction by obsessively watching or following sensational or sordid subjects, which is exactly what people do when they monitor, whether it's deep packet inspection or monitoring of any kind. I'm going to talk about scope, effectiveness, and risk. When people mention the tenets, the IA tenets, the tenets of information assurance, they talk about confidentiality, integrity, and availability. Today, I wish to introduce the three tenets of scope, effectiveness, and risk. Whether it is a policy or a tool, whether it is a gadget or a piece of equipment, ask the questions, what is the scope? What does it do? How effective is it at doing it? And does it add any risk? Those three tenets are founded in papers written, principles presented by David Hume in 1739, the Scottish philosopher, who talked about the induction problem. There can be no demonstrative argument to prove that instances of which we have had no experience, that's the future, resemble instances of which we have had, that's the past. David Hume, in a very eloquent way, predicted in 1739 that cyber defense will fail because we use past behaviors to predict future behaviors. There can be no demonstrative argument. Hume addresses the effectiveness of cybersecurity and monitoring. On the other hand, Bob Kahn, when Robert Kahn and Vinton Cerf developed the TCP/IP protocol, invented the internet in 1972, they introduced a layered approach that defines our scope for us. They talk about the asymmetry in the layers. To this day, I remember my very first day in graduate school when I discovered the genius of Bob Kahn and Vint Cerf, who discovered that the only way we can build an internet is if we break data into packets. This genius of packetization has led to layering, in which a failure at layer n can only be recovered from at layer n+1. To give a physical engineering example, if you put a bomb in the basement of a building, the odds are the building will come down. That's attacking the physical layer. Yet, if you have an incredibly good foundation and somebody flies a plane in the 83rd floor, the building will come down. So people who are obsessed with hardware root of trust are missing all the attacks that are occurring at the transport layer, at the session layer, at the presentation layer, at the application layer. And Kahn had defined that asymmetry very, very well in what became known as the International Standards Organization Open System Interface Reference Architecture, the ISO-OSI model. Jim Anderson was an Air Force engineer at Hanscom Field when IBM changed from using punched cards, batch processing computers, and introduced at the time CMS, or the conversational monitoring system, that allowed multiple users to use the same computer at the same time. Anderson was concerned that with resource sharing comes security risks. To this day, 1973, 2020, every time we look at a potential cyber vulnerability, bar none, resource sharing is the primary problem that we deal with. So as we talk about monitoring, we ask, are you sharing any resources with the mission that you are monitoring? And if so, are you introducing the risks that Anderson worried about in 1973? That is in a nutshell the talk, so I will define the word monitor as a verb. Oxford Dictionary: observe and check the progress or quality of something over a period of time. Keep under systematic review. Dictionary.com: observe, record, detect. With instruments that have no effect upon the operation or condition. That have no effect upon the operation or condition is invoking the risk piece. The Merriam-Webster: watch, keep track of, or check, usually for a special purpose. Collins comes spot on. Observe or record an engine or other device or its activity or performance. This kind of monitoring I am comfortable with. I've had a fascination with numbers ever since I was a kid. I played chess in high school, and the ELO chess rating, the number that defines how good I am, I lived by that. I computed it after every game, and I knew exactly what my ELO rating was at any hour of the day. I also learned how to count calories for the fun of it. And my father, who was an accountant, taught me finances, and I was balancing my books, so to speak, ever since I was a teenager, what went in, what went out. In college, there were 5 of us that entered into an interesting contest which said, anybody who gets 100 on a quiz, the rest of the group will buy him a piece of Black Forest cake from the bakery across the street. I ate a lot of Black Forest cake during my undergraduate engineering education. I also learned about volts and amps. I went to the American University of Beirut, 1975 through 1979, 4 years of war, during which Lebanon had no electricity. So we learned about volts and amps at the light of a candle. Hard to relate to electricity when you don't have any. We also learned about ceasefires and started counting the days before every one of them failed and the shooting began. Fortunately, the counting that really mattered was how many more days are left, plotting that versus how many more students are left. The 27 who started, 18 graduated eventually. And this was my fascination with numbers in college. Postgraduate school at the University of Salford in Manchester, England, I learned about group delay distortion, about bit error rates, about packet loss. And we started counting these. I could tell you exactly by looking at the system how many milliseconds of group delay I can expect at any given frequency. At work, fascination with miles per gallon, given my long commute, and my running how many miles per week, and how these two impacted my weight. And then the COVID era, I started keeping track of my blood pressure, because that's what my doctor said I should do, of COVID-19 infections, but most importantly of my 401k to detect the right time to bail out and retire, basically. So fascination with numbers. When I look at those 4 pictures, they ring a bell. On the left side, the 2 sides of one coin, performance. We understand altitude, we understand speed, we understand pressure. We can measure them, we can monitor them. In the medical setting, we can monitor blood pressure, we can monitor heart rate, we can monitor oxygen concentration in the blood. On the right side of that picture, we have a bunch of Air Force officers dressed in flight suits, looking at screens, trying to monitor security. Everything on those screens cannot be measured. These are not metrics that make any sense. Monitoring, in their case, is a futile exercise. Today, my goal is not to prove to you that cybersecurity or cyber defense does not work. We know that. Today, I'll be explaining to you why it does not work by looking at some fundamental science that explains, demonstrates, and proves that if you're monitoring your computer or your network in order to detect attacks, you will fail. It is proven mathematically, and that's what we will talk about. Dorothy Denning, 1987, and that's not a typo, introduced intrusion detection. Security violations can be detected by monitoring a system's audit record for abnormal patterns. If anyone in the audience believes that the internet has not evolved since 1987, over the past essentially 33 years, 40 years when her research began, if anyone is convinced that the internet has not changed, has not evolved, then please keep monitoring in order to detect security violations. We're talking about 40-year-old technology, did not work then, does not work today, never worked in between. Yet if this is what you're interested in doing, go at it. 3 slides worth of facts, truth, and opinions. Quantifying the dependence of a mission on cyber is important. You must be able to monitor performance metrics on which your mission depends. When I ask a commander, does your mission rely on cyber? Of course, everybody's does. How much cyber do you need? The answer is almost immediately, what do you mean? How much information generation? How much sensors do you need? How many overhead sensors? How many MQ9s do you need? How much bandwidth does your mission require? In the early phases of the war, around 2001 or so, the Air Force required about 4 gigabits per second per squadron to prosecute the mission. We computed that number, we had a good idea. Today, with the obsession with the live video feeds, there is no limit as to how much bandwidth we can use, not that we need. Information processing, how much computing do you need? How much storage? And then information consumption and destruction. It was Admiral Mullins, as chairman of the Joint Chiefs of Staff, who asked his combatant commanders to quantify the dependence of their operational plans and contingency plans, or plans and con plans, to quantify their dependence on cyber. I advocate the creation of a cyber equivalent to the Civil Reserve Air Fleet. That's what the Air Force negotiated with the major airlines, the use of their capacity to transport troops in the event of a contingency. We must be able to quantify now what that is in cyber and negotiate now, today, with the AT&Ts and Verizons of the world, our requirements for cyber, so we can ensure that the mission will be able to succeed based on how much information generation, transmission, processing, storage, consumption, or destruction we need. Mapping the dependence on cyber on those parameters of a mission is absolutely critical to the success of a mission. And we must be monitoring these. We must know that we have that stuff to get the mission done. Second, fact, truth, opinions. A successful cyber attack against a computer may or may not impact its performance metrics. There is a myth that says if somebody attacks us, by looking at the performance, we must be able to tell that CPU cycles are changing, that memory consumption is changing. No, not necessarily. Somebody can change 1 bit in 1 byte on your computer and result in a mission failure. Do not assume, it's a wrong assumption, that an attack will result in changes in performance metrics. The third fact, the first bullet here is mind-boggling to many, namely that the bad guys use the same tools, same monitoring tools as their victims. That the bad guys are actually testing their attack tools against the very same defenses that we are using before they launch them. Why would anyone launch an attack if they know it's going to be detected immediately, especially if they can buy the same tools that we are using? So when we look at monitoring tools, intrusion detection tools, virus scanners that are signature-based, remember that it was the bad guys who generated those signatures in the first place, and they know very well how to avoid them. Whitelisting, blacklisting, normal, abnormal, forgets the fact that the adversary gets a vote. It is trivial to create traffic that does not conform to what you're expecting or does conform to what you're not expecting. And lastly, cyber monitoring cannot account for intent. Since Steve mentioned the ACE, I challenged our ACE graduates, and we have about 500 of them now. I said, can you find one instruction, one command in any programming language that cannot be used for good and bad to avoid multiple negations? Every instruction in every programming language could be used for good or for bad. The only difference between whether that execution is good or bad is intent. Cyber monitoring cannot account for intent. If you see a delete file, an encrypt file, a copy file, how do you know if it's good for good or for bad? Monitoring does not. I mentioned scope, effectiveness, and risk. And I posted that these three metrics, these three tenets, are inspired by Kahn for scope, Hume for effectiveness, and Anderson for risk. Before you buy a tool, before you approve a policy, before you pass a law, ask, what is it looking at? What does it do? What percentage of traffic are you inspecting? What layer are you monitoring? And how well are you doing within that scope, effectiveness? How much is the adversary doing outside your scope? When people say, we're monitoring, we're doing deep packet inspection, we ask, what percentage of traffic are you able to look into? Well, we cannot look at encrypted traffic. We don't look at Stego. We only look at what's coming through port 80, and the list goes on and on. Okay, so you're monitoring about 10% of traffic. What is your effectiveness over that 10%? I can tell you right away, it's zero, simply because any equation that you come up with to compute effectiveness is ignoring the denominators. All those attacks that you have not detected yet that are there, all those intrusions, all that malware that you are not aware of yet, the denominator ensures and guarantees that your effectiveness is going to be zero, regardless of your scope. And then risk. I have yet to see a monitoring system that does not pose a risk to the mission that it claims it's defending. We forget for a moment the threat. When we talk about Byzantine fault analysis, we are jumping directly from the vulnerability to the consequence. If a vulnerability were to be exploited intentionally or accidentally, what is the consequence? If a B-2 aircraft, if one pitot tube were to give a wrong reading to the computer on board, will that cause a $2 billion plane to crash in flames? Yeah. That is a Byzantine failure. No one said it was a cyber attack. Could it have been a cyber attack? I don't know. Could it be that somebody sent an email to an operator, to a maintainer, and said, you will calibrate those pitot tubes differently at Anderson Air Force Base in Guam than you would at Whiteman Air Force Base in Missouri because of the difference in humidity? The official accident investigation said the maintainer did not read his email. And that's what I say. Email is cyber. Therefore, this was a cyber mishap. Byzantine mishap, but it was cyber. And it caused a major mission failure risk. I shall not burden you with the metrics in every one of those parameters, but I spent much of my graduate school measuring random noise, impulse noise, attenuation, amplitude distortion, phase shift, phase distortion, transmission delay, etc. These are quantities we can compute, we can quantify, we can monitor. I can tell you with certainty, if one of those parameters goes outside certain boundaries, that your mission will suffer. There will be disruption, degradation, possible denial of the mission. We also monitor CPU usage, chip temperature, cache miss rate, page fault rate, number of threads, number of processes. Yeah, these are performance metrics that you must monitor for your mission. In their own words, these are the manufacturers who sell us those products. Our monitoring system allows deep packet inspection of hundreds of protocols for live capture and offline analysis to provide an accurate understanding of slowdowns. And it tells us how much bandwidth each device and application is using, identifies sources of bottlenecks. Yeah, that is good monitoring. I'm all for that. Physics does not suffer from the induction problem. The past will not There's no problem with the past predicting the future when it comes to time, current, weight, physical parameters that are well known. We maintain accurate references, we calibrate for accuracy and precision, and we allow for repeatable measurements. I am good with the effectiveness of performance monitoring. For those who are fascinated with the movement of atoms in atomic clocks and the impact of gravity on them, we realize that if you move an atomic clock from sea level up all the way to the top of Mountain Washington, then that clock is going to be running slightly faster up there than it would at sea level because of gravity pull on the atoms inside the atomic clock. And that is an experiment that can be conducted, that can be measured. So when you put a whole bunch of GPS satellites in orbit with atomic clocks on them, and they're going round and round the Earth, and the Earth gravity on them is changing based on whether they are over the pole or over the equator, that creates for an interesting Kalman filter solution to compute what time is it really at any given moment. Yeah, this kind of performance monitoring is absolutely necessary. The Heisenberg uncertainty principle comes into play because measuring a quantity may introduce an error in the quantity being measured. There was a question on a running chat that I belong to, the Marathon Maniacs, asking, why does counting calories not work? And my answer was, of course, it's the Heisenberg uncertainty principle, because you burn calories to count calories. That may not have been the intent of Heisenberg, but resource sharing. Does the monitoring instrument require resources from the system that it is monitoring? If it does, then if that monitoring instrument were to fail, can it cause a problem? If you insert an amp meter in a system to measure the current flow, if that amp meter were to fail, will it impact the mission? In that case, of course it will. If it fails open, current stops flowing. If you put a voltmeter and it shorts, it's going to give you a problem. Remind you of Byzantine behavior. Can a malfunction in your monitoring instrument affect the system? If it does, can that be done maliciously? Now we go to security monitoring and look at definitions in their own words. It's the collection, analysis, and escalation of indications and warnings to detect and respond to intrusions. I put those little numbers to indicate that every one of those terms fails a rigorous measurement test for it to qualify as a useful metric. How do you measure an indication or a warning to detect an intrusion? Aggregate relevant data from multiple sources, identify deviations from the norm. What is the norm when you have no idea what the denominator is? And what quantity are you aggregating to define a norm? And would a cyber attack against the integrity of your data cause any deviation from whatever norm you picked to monitor? The answer is no. Collection of data from a large range of systems, collection monitoring of logs. Take my word for it, anybody who's able to hack your system can modify your logs as well, unless you're using the old IBM method of having your logs printed on a line printer sitting inside a vault in a different continent than the computer that you are monitoring. Now the user, that attacker, can really not modify the log. Security monitoring scope. Computer monitors versus network monitors, and you can buy any and all of these. The distinction between monitoring and intrusion detection blurs quickly. The former claims to provide the means for the latter. Anyone and everyone who is selling an intrusion detection system claims that they are monitoring to detect intrusions. In their own words, A computer monitor uses the system logs containing events that have actually occurred to determine whether an attack occurred or not. By the way, to set the record straight, I have no interest in detecting a failure in an Air Force mission. Anybody who's talking to me about detecting things after they occur are missing the fact that our job is not to detect failures. Our job is to be against failure. That is my new puppy. She does not like me when I talk about mission failures. Monitors executable system calls using APIs, detects anomalies. What is an anomaly in a system call? I can make sure that I can get the same system calls and have them operate on the wrong data and cause a mission failure. Delivers breach detection, remediation, and compliance. I have no interest in breach detection, remediation, and compliance, especially compliance. I want to make sure my mission does not fail. Malware detection, log management, change detection, configuration assessment, every single one of these fails literally millions of times a day. It continuously monitors critical operating system application and log files at scale, extends file integrity monitoring across the entire organization. Timeout. Can this be an attack vector? And the answer is yes. More on the effectiveness. Computer monitoring depends on signature or string matching to detect threats. And these can be defeated by simply changing a tool enough. That's in their own words. Log file checkers run regularly and parse system and application logs to search for signature-based alerts. Well, if you do not have the signature for a new alert, because, by the way, those who created the malware that caused the signatures are the same ones creating the new ones. Attackers who compromise a host can attack and subvert host-based monitors as well. That's in the words of those who write those monitors. The master algorithm by Pedro Domingos talks about the biggest sin of monitoring for intrusions. How can we ever be justified in generalizing from what we have seen to what we have not? Every learning algorithm is, in a sense, an attempt to answer this question. This is no different from what David Hume said in 1739. There can be no demonstrative argument to prove that instances of which we have had no experience resemble those of which we have had experience. The most important problem in machine learning is hallucinating patterns that are not really there. When our vice chief of staff contacted me, just retired on Friday, General Wilson, Savvy Wilson, said MIT has a new system that will detect 97% of all intrusions. Shall we use it? My answer to him was, sir, let me find out how they computed the denominator. And they computed it by using the Lariat dataset. Doesn't everybody use that dataset? Actually, no. The bad guys don't use your dataset when they create malware to make sure you can detect it. The risks of computer monitoring. It was Jim Anderson in 1972 who wrote, large software packages that sit between your application and your operating system exact a very large price for storage space and execution time and offer little protection against a hostile programmer. For those of you in government service, thank you for your service. And I regret that you have to see that round and round thing which says not responding or waiting for Windows or whatever it is, every time you click on any file, it is those large packages sitting between your application and your operating system that are using up between 90 and 99% of CPU cycles and memory to look for signatures that they will not find, because if anybody wants to attack the system, they're not going to use a signature that you already have anyway. In 2018, that's decades after Jim Anderson's concern, an audit file overflowed a log file and rendered a weapon system non-mission capable for several days. Exactly the concern that he was talking about. Outside of the DoD, 2019 was a bad year for remote monitoring advocates because the great majority of attacks, according to one study, 74% of all attacks against North America, cyber attacks, used the remote monitoring and management tools as the attack vector. Because when you give someone administrator access to your machine remotely, then they don't have to get into every single machine. They get into one place only and they own the system. The 22 Texas counties that were taken over in August of 2019 were an example where the attacker attacked the managed service provider and from it owned all the machines for 22 counties. More recently, according to open source reporting, Iranian malware that hit the Bahrain Petroleum Company, they used the antivirus management service account to distribute malware across the network. Another case where monitoring created a major risk. Network monitoring, on the other hand, utility for network discovery and security auditing. Network discovery, I have no problem with. Security auditing, I do have a problem with. Monitoring host or service uptime, that is okay. What hosts are on network service applications, they're okay. Detects, reacts, and responds to emerging threats using packet or flow-based traffic analysis, you will never see it. An attack using packets onto your system, believe me, you will never detect it. If the attacker encrypts the payload, if the attacker is using protocol steganography, if the attacker modifies the integrity of a single bit in an option field, if an attacker uses DNS, domain name service, to communicate covertly in and out of your system, your network monitoring will not detect it. When somebody misspells things, it's usually an indication that A, they're nervous about what they're talking about, or B, they have no idea what they're talking about. And in this case, if you read this sentence or this paragraph, that's what my PhD supervisor used to tell me in England. That is what rubbish is. A collection of English words that make up an overall grammatically correct sentence that has absolutely no meaning. Providing comprehensive capabilities that accelerate threat detection, investigation and response, combats threats with actionable intelligence, advanced analytics at scale. This is rubbish, by the way. Reduces time to detect, ingest data from cloud or on-premises to quickly detect malicious threats and detects unknown threats using machine learning. Again, this is the definition of rubbish. The sentence is correct grammatically, but has absolutely no meaning, no utility. Uses detection rules to examine network traffic to look for patterns that indicate a known threat. And that's the operative term, known threat. What do you do about unknown threats? I don't know. So when somebody wishes to sell you a network monitoring tool or institutes a network monitoring policy, ask the questions. Is it conducted online or offline, in band or out of band? At what protocol layer? And that is important because you can monitor all day long at the network layer and miss everything above it and below it. Does it inspect encrypted payloads? Does it examine end-to-end VPN? Does it look for data or protocol steganography? I can embed protocols inside protocols all day long, and your network monitoring will not even have a clue that I'm running a totally different IP protocol embedded in IPv4. And it will go undetected, of course. Can it detect time domain covert channels or frequency domain exfiltration? Is it stateless or stateful? If and when you get convincing answers to all of these, that's a good start. My bet is you will get a blank stare and no to the ones that are not blank stares. The effectiveness of network monitoring, pattern-based monitors, that's what David Hume's induction problem is. They're going to fail at detecting anything unknown to them. Anyway, when you try to determine a baseline of normal traffic to detect abnormal patterns, you are going to fail. Now, the risk of network monitoring has become my preferred attack vector. Can the monitor leak data across security domains? When they say it's one way only at what layer? If you are using a free space laser with a signal source and a signal detector, two separate power supplies from two different utilities, then I am convinced it is one way. However, can that one way cause data to be leaked from the high side to the low side? Can the monitor modify, inject, or subvert data? The answer is probably for most of them, yeah. And what happens if the monitor fails in a Byzantine manner? Can it impact your mission? Can it delay or delete data? If I know how your monitor works, especially if it seeks to delay duplicate packets or anything like that, I can leverage that as the attack vector and have your monitor kill your mission, so I don't have to do it. In conclusion, scope, effectiveness, risk. Hahn, Hume, Anderson. If you have the time and the curiosity, you may want to read David Anderson's Treatise of Human Nature, 1739. It's a good book. You may want to read Jim Anderson's report from Hanscom Field about the risk from resource sharing. And you may want to pick up some requests for comments and read about how the internet was created and the relationships among IP, TCP, and DNS. They will help you quantify those three parameters. But when someone creates a new policy, apply those three metrics of scope, effectiveness, and risk to the policy and see whether it is really worth adopting. Before I get off my soapbox, I want to talk about the difference between efficiency and effectiveness. On the right side, effectiveness. We know for a fact, we can demonstrate it mathematically, that intrusion detection and prevention has failed, malware and virus scanning have failed, traffic scanning and monitoring have failed, deep packet inspection has failed, attestation, whitelisting, blacklisting, configuration management, firewalls, cross-domain guards, packet filters, signing, hashing, passwords, two-factor authentication, they have all failed against advanced threats. They are ineffective in what they are proposed to do. Now, some people believe that artificial intelligence, machine learning, I had a couple of slides earlier that showed that command and control, automation, autonomy, and big data analytics can improve cyber defense. The answer is yes. They will improve the efficiency, but not the effectiveness of failed processes. Big data analytics, AI, machine learning, command control, automation, and autonomy will ensure that those systems will fail a lot faster and a lot more frequently than they do without that help. We can have a separate talk about the role of artificial intelligence in cybersecurity, but take the biggest lesson from it of scope, effectiveness, and risk. And the biggest one is that not only does AI not improve the effectiveness, it increases the attack surface through adversarial learning. I can use AI to attack your system, knowing very well it doesn't work to start with. These were my prepared slides. I'll be happy to take questions.
Thank you, Kamal. That was a very interesting presentation. A lot of food for thought there. So we do have some questions from the attendees. So let's jump into those. And so one of the questions one of our attendees wants to know is, how can you accurately detect or determine the denominator? How do you come up with that figure?
You cannot, because as we saw in 2019, 74% of cyber attacks in North America did not use malware. So even if you knew exactly, if you want to play mathematically and say the total number of viruses out in the wild is finite. We don't know what the number is, but it is finite. And if we go from there, and we can pick some ranges of numbers of that, what might be, that's only taking care of those attacks that do require a denominator, when the overwhelming majority, 3/4 of them, did not, and focused only on leveraging your tools to make you fail. They're looking at managed service providers, at remote monitoring. They're targeting the integrity of information as a way to attack your system. And this is where the knowledge of that denominator, that delta, becomes moot, because only a minority of attacks worry about it.
Okay, thank you. So another attendee wonders, do you expect the forthcoming use of quantum computing to lower the cost of security from legacy computing systems?
No. For those who lived in the era of gallium arsenide about 3 decades ago, when it was labeled as the technology of the future and will always be, that's one way of describing quantum computing now. It is the technology of the future and will always be. I do not see quantum computing as playing any role in mission assurance.
Okay, thank you. So one of our attendees, his question is, so what strategy should be used or could be used in order to better defend your organization?
What is your mission? How does it depend on cyber? What are the potential vulnerabilities of that dependence that could cause mission degradation or failure? And how do you mitigate those vulnerabilities? These are the 4 steps that both the Department of Defense and the rest of the world have adopted for mission assurance. In practical terms, the mitigation part is going to force us to abandon our obsession with trust and focus on risk. I no longer seek to build trusted systems out of trusted components, because we no longer build hardware, write software, specify protocols, own networks, control users, but rather I seek to compose mission assurance out of untrusted components. We have had several successes by building a stochastic layer 8 on top of the 7 layers of the internet protocol that are deterministic. By introducing that stochasticism, we were able to shift from, do you trust the mission or don't you, to what is the percentage likelihood of mission success over a finite amount of time, which is the duration of the mission, and then the commander can make the decision whether to take that risk or not. So the trade-off for us is not defending a network. The trade-off is assuring a mission over its useful life.
Okay, and I'm going to piggyback. A question came in while you were answering that, and so basically, are you saying that resilience is the only path to success in achieving mission assurance?
No. If you look up any English dictionary, resilience means recovering from failure. I have no interest in going there at all. I do not want a resilient missile defense system that can recover after every failure. I am seeking robustness, whereby the mission will succeed regardless what else goes on around it. And the will succeed part is going to be stochastic, that it has a 99% chance of succeeding, a 95% chance, a 90% chance. Operating on computers we did not build, networks we don't own, software we did not write, all the uncertainty of untrusted components. No, resilience is a bad word in the English dictionary. I have no interest in recovering from failure.
Okay, thank you. So there's a couple other questions here, and I think they're related. So I'm gonna throw the two at you. So first, the individual wants to know if he's correct in understanding that you think signature-based detection is a waste of time and resource, and you shouldn't do it. And the other question is, and if all tools like firewalls, IDS, and so on failed, what should be used to enhance the effectiveness and efficiency of monitoring tools?
The first question, no, it's not a waste of time. It is actually a very useful attack vector if you're the bad guy. Show me a DCO tool and I will show you how I can use it to attack your mission, your system. Which brings RMF, Risk Management Framework, very quickly with its 8,000 plus IA controls, information assurance controls. Not a single one of those controls is either necessary or sufficient for mission assurance, yet every single one of them can be leveraged as an attack vector. Every time you implement an IA control, you are reducing the security of your mission. Which brings us to firewalls. Yeah, they do not work. The guy who invented the firewall said in no uncertain terms, you're using them for the wrong purpose. They are not intended. They were never intended to be a security device because they do not work. They're operating at the wrong layer anyway. Cross-domain solutions, cross-domain guards, same story. Because they use resource sharing, they are violating Anderson's basic premise that resource sharing creates a security vulnerability. We can go through them all day long in both directions with impunity. What would you do instead? You do not worry or focus on the security of your network. You focus on assuring your mission over a finite amount of time against advanced threats. It's when you change your focus, when you change your thinking, when you change your outlook from I am complying with the NIST framework, therefore they will blame somebody else when the mission fails, to I have a mission to do and I cannot afford for it to fail under any circumstance. Now we're talking on the same wavelength.
And so another attendee wants to know, he says, what if his mission is securing the network?
Okay, this is being recorded, so I'm not going to suggest considering retirement yet for him. It's a waste of time, talent, and energy. It is a mission that is intended and designed to fail. But he will have the luxury of blaming the tools that he's stuck with that they did not work in the first place.
So there's a question, let's see. This stochastic mean encrypted, I'm not sure that's, I don't know if you have a comment on that.
What was the question?
It was, does the stochastic mean encrypted?
No, it does not. It means it is imperative for our cyber warriors to have an education on the science of information assurance and then a training on the art of cyber warfare. I took 3 years of graduate education on stochastic processes and how they differ from deterministic processes, and it has absolutely nothing to do with encrypted.
Okay, thank you. So another individual is wondering, so to improve mission assurance, is the optimal solution to lessen the reliance on cyber systems?
No. I don't know how you're going to build and launch a satellite to observe the weather without using any information in it. I mean, God created the electromagnetic domain as early as Genesis chapter 2. We cannot live without electromagnetics. We cannot live without information. And when you look at no bit, no binary digit has ever been generated, transmitted, stored without using electromagnetic waves, then to say that we're going to lessen our dependence on cyber. If you're a Marine and you'd rather use an M16 and a paper map than GPS and a guided weapon, that's fine with me. I have no problem with that. But for the rest of civilization, our dependence on cyber does not afford us the luxury of saying, I'm going to go live in the woods and never see a bit ever again generated, stored, transmitted, consumed, or processed.
Yeah, I think there's a few folks, a handful of folks, kind of living off the grid, but most of us, it's just kind of become the basic fabric of our existence now. It's really everywhere. So let's see. So another individual was, with new autonomous vehicles and things of that nature. What do you see as the potential cyber risks there? As some kind of a hacker or terrorist, hacking into a vehicle like that and using it as a weapon?
I am an early adopter of technology, and I am an early developer of technology. Today, we're working on building an unhackable satellite. We're working on building an unhackable aircraft. If you accept the premise that every computer program is an instantiation of a mathematical formula, then if you can specify mathematically the mission that you are building and automate the code generation from that mathematical specification and then verify that the implementation satisfies the security properties of the specification, then you have built yourself a system that cannot be hacked because it does not have vulnerabilities. Short of a sledgehammer, it will carry its mission against any and all cyber threats. We have demonstrated that so far 3 times. And today we are working on building an unhackable satellite, one that will adopt just-in-time mission composition, whereby the instruction length, the architecture, the addressing modes, the number of registers, everything that goes into generating, processing, storing, consuming, transmitting information is defined at the instant of the mission being composed. Then there is a high likelihood that nobody has developed malware yet against an instruction set that did not exist 2 minutes ago. The mission is launched, and then when the mission is done, you can scrub it and have yourself a blank aircraft or a blank satellite and repeat for the next mission. We know how to do it. We just need the policy makers to get off our backs, because such a system will not comply with any of the 6,200 policies that you have on your nice chart on the CSIAC website. Oh, by the way, that will make for a good talk, because every single one of those policies violates my scope, effectiveness, and risk metrics.
Okay, well, we'll schedule that for another talk then. So
we know how to build systems that will accomplish their missions in a contested cyber environment. Math is on our side. We know how to do it. We just need the will to do it. And by the way, it costs a lot less.
So basically, I mean, is that kind of using the formal methods approach to developing the secure software?
No. Using formal methods to verify that the implementation satisfies the original specification.
Gotcha.
Yeah.
Gotcha.
If you try to use the formal methods at the wrong time, you're going to have a state space explosion and you'll never get anything out of it.
Okay.
I'm saying specify your mission mathematically. We have to be able, when we write a request for proposals, to ask every company submitting a proposal to not use English, but use some other programming language like higher order logic or access control logic to submit their proposal in math, showing us what they want to build. So when they deliver it, we can verify that they built what they said they will build.
Sounds good. Sounds great. So I want to thank you, Kamal, for taking the time to share this presentation with us today, and it's very informative and thought provoking. And once again, just want to let you know that we greatly appreciate your sharing your experience with us here.
Thanks, Steve. Thank you, ladies and gentlemen, and wish you a good rest of the week.
Okay, and I'll just make one note for our December webinar that's going to take place on the 2nd, and that'll start at 11 o'clock in the morning, and that's going to be on the Vulnerability Disclosure Program, the DoD program, VDP. So hopefully you can join us for that presentation, and I hope everybody has a good day, and we'll see you next month. Thanks. Bye-bye.